This video is going to show you how to do all the problems on the Statistics and Probability Study Guide. If you have any additional questions, please bring them to class so that I can help you further. So number 1, a bag contains 3 red marbles, 9 blue marbles, 3 green marbles, and 3 yellow marbles. Determine whether each statement correctly describes the likelihood of an event. Select true or false for each statement. The probability that a purple marble is selected is 0. So the probability of it being purple, if you look back up here in the information provided, you'll see that there's no purple out of 18 marbles. I got 18 because I added 3 plus 9 plus 3 plus 3, because that equals 18. And 0 divided by 19 is 0, and that would show that it's an impossible event, or the probability is 0. All right, so that's true. Okay, the probability that a blue marble is selected is 1/2. So let's find the information here. I see that there are 9 blue marbles out of the 18. 9/18 simplifies down to 1/2, or 0.5, or 50%. So that is true. Okay, the probability of selecting a green marble is 1/2. So you got to determine if that is true or false, and I see that there are 3 green marbles out of the 18. 3/18 simplifies down to 1/6, and that is not the same as 1/2, so that is false. Okay, if I make a mistake throughout any of this video, please let me know so that we can correct it. Okay, a bag contains 3 marbles, 3 red marbles, 3 blue marbles, 3 green marbles, and 9 yellow marbles. Determine whether each statement correctly describes the likelihood of an event. Select true or false for each statement. The probability that a red, blue, green, or yellow marble is selected is 1. So we're looking for the probability of red, or blue, or green, or yellow. That says or. Okay, so probability of it being red, when I add them all together, it's there's 18 marbles in there. So the probability of it being red is 3 out of 18. Or would mean add in probability. Blue marble is 3 out of 18. Green marble is 3 out of 18. And the yellow marble is 9 out of 18. So when I add 3/18 plus 3/18 plus 3/18 plus 9/18, I get 18/18. 18 divided by 18 is 1. So the probability of that, of any of those colors getting selected is 1, or 100%. So that's true. Okay, the probabilities of selecting a red, blue, or yellow marble are the same. So I kind of have the information right here. So red was 3/8, 3/18, blue was 3/18, and yellow is 9/18. So they're not all the same. So that's false. The probability of selecting a green marble is 1/6. So let's check probability of getting green. Green, there were 3 out of the 18. 3/18 simplifies down to 1/6. So yeah, that's true. Okay, bag contains 3 red, 3 blue, 9 green, and 3 yellow marbles. Determine whether each statement correctly describes the likelihood of an event. Select true or false for each statement. Probability of selecting a red marble or blue marble is 1/3. So we're looking for probability of red or blue. So probability of getting a red marble is 3 out of, let's double check, make sure there's 18 marbles in there. 3 plus 3 plus 3 is 9. 9 plus 9 is 18. So yeah, there's 18 in there. And 3 of them were red, or would mean add in probability. Blue marbles, I know it's out of 18. How many blue are there? 3. 3/18 plus 3/18 is 6/18. That simplifies, so I can divide by 2, divide by 2. That would be 3/9. 3/9 I can simplify even further. I'll divide by 3, divide by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So probability of selecting red or blue is 1/3. That's true. Okay, the probability of selecting red marble or blue marble is 6/18. Well, I just found that out up here, so I thought, yeah, that's true. I see 6/18 right there. The probability of selecting a red marble or blue marble is 3/9. Yeah, see, these all are equivalent fractions. A radio station is giving away shirts. In the box of t-shirts, there are 12 small, 5 medium, 24 large, and 9 extra large shirts. Select true or false for each statement. Caleb wears a medium. It is unlikely he will get his shirt size. So let's try to find here. Probability of getting a medium. I'm abbreviating right there. And I got to figure out, well, how many of them are medium. There's 5 of them out of how many shirts total? There's 24 plus 5 plus 12. That's it. Oh, plus 9. And that equals 50. So there's 5 out of 50. 5/50ths, that could simplify down to 1/10. Because I went divide by 5, divide by 5. 1/10 is, like this as a decimal, that's 1/10. Or you could say it's 10%. So it's saying it's unlikely he'll get a shirt size. So if you remember back from the notes, that like continuum of probability, it goes from 0% chance, which is an impossible event, to 100% chance, which is a certain event. Right in the middle is neither likely or likely, neither unlikely or likely. Right here would be like unlikely. Over here would be likely. So 10% would fall like close to over here. So yeah, it's unlikely he's going to get a shirt size because it's only 10% chance. Evan can wear a medium or a large. It is likely he will get a shirt that fits him. So probability of a medium or large. Let's see, the probability of him getting a medium. I should have wrote this somewhere else. Medium is 5 out of the 50, plus the probability of him getting a large is 24 out of 50. 5/50ths plus 24/50ths is 29/50ths, and that's about, 29 divided by 50 is 0.58, which is 58%. So yeah, it's likely, because it's over half, so it's likely that that will happen, so this is a true statement. Okay, the radio station gave away all the shirts in the box. About half of the people who received a shirt ended up with a large. So what was the probability of getting a large? 24 out of the 50. Yeah, that's almost half. 0.48. 24 divided by 50 is 0.48, which is about 48%. So about half the people, yeah, about half. 48% is almost 50%. So that's about half. Okay, Madison's planting a garden, but all of her seeds got mixed up in a bag. The bag has 3 carrot seeds, 6 tomato, 12 cucumber, and 9 watermelon seeds. She decides she'll reach into the bag and randomly pull out seeds. Select true or false for each statement. It's unlikely that Madison will pull out a carrot seed. So let's find the probability of pulling out a carrot seed. I see that there are 3 carrot seeds in the bag of 30. 3 divided by 30. Well, 3/30 simplifies down to 1/10 because I'm dividing the numerator and denominator by 3. And 1/10 as a decimal is 0.1, which is 10%. So yeah, that's unlikely. Okay, pulling out a watermelon seed is an impossible event. So let's see what it is. What is the probability? Probability of watermelon. And the probability of getting a watermelon is 9 out of 30. That's not impossible. If it was an impossible event, it'd be 0 out of 30. So that's false. Okay, when she first reaches into the bag, the probability of grabbing a tomato seed is 1/5. Let's find the probability of getting a tomato seed. Probability of getting a tomato seed, 6 out of 30. 6/30 simplifies down to 1/5 because I'm going to divide by 6. Divide by 6, 1/5. So that is true. Okay, Ms. Hopkins is giving away Jolly Ranchers as prizes. In her jar of Jolly Ranchers, there's 10 blue raspberry, 24 watermelon, 48 grape, 18 cherry. Determine which state or whether each statement correctly describes the likelihood of an event based on this jar of Jolly Ranchers. Okay, Olga's favorite is cherry. It's unlikely she will get her favorite flavor. Let's find the probability of getting cherry. And I see that it is 18. Wait, no, it's not. Yeah, 18 out of... Now, the grand total of them all, when you add up all of the Jolly Ranchers in there, is 100. Oh, it says it's likely. Okay, so 1800ths, it looks like this has a decimal, which is 18%. And it says it's likely she'll get her favorite flavor. No, that would be unlikely. Anna's favorite is green apple. It's certain she will get her favorite flavor. I didn't even see a green apple up there. So the probability of getting green apple is 0 out of 100, so that's an impossible event. So that's false, because certain means she's for sure going to get it. There's a 100% chance she'll get it, but there is no chance she'll get it, so that's definitely a false statement. Mrs. Hopkins gave away all her Jolly Ranchers. About half the students got blue raspberry. So it's probability of getting blue raspberry. Probability of getting blue raspberry was 10. 10 out of the 100. About half. No, 10 out of 100 is not about half. 50 out of 100 would be half, so this is also a false statement. Okay, if you have any questions on this front page, please make sure you jot them down, write them down so you can ask them later. If there's something you don't understand, you have to tell me so I can help you. Mark and Caesar's scores in different subjects are given in the table. Determine whether each statement about the data is true. Okay, so it looks like we got to find the mean of Mark's score because they're trying to ask you if it's less than Caesar's. And then it looks like we got to find the median of both and then the range of both because we're comparing it. So instead of just trying to do each one right now, I have room right here to just write down the data so I could figure it out. I'm going to have Mark's right here. I'll write all of his information here, and then Caesar's. And first thing we're looking for is the mean. So to calculate the mean, think about what you would do to find the mean, because you need to have that memorized for your test. If you're an adult and you don't remember it, you'd probably look it up. But for all these like NWEA and SBACs type stuff, they're going to want you to memorize that. So a mean is you add up all the numbers. So add those up right now. And then press equals. And then you will take that number and divide it by how many there are. So take that total and divide it by 1, 2, 3, 4. Divide it by 4. And you're going to do that yourself, okay? So check and see if you're right. The mean that I got, unless I'm wrong, is 42.5 for Mark. For Caesar, again, add them all up. Press equals. Then divide by 4 because there are 4 numbers there. Okay, and you check your answer, you should get 45 and 75/100ths, okay? And then the median, to find the median, because that's so the mean of Mark's score is less than the mean of Caesar's score. So is this one less than this one? Yeah, that's true. And look right here, it's written backwards, so always double check to make sure you're following the correct box, you're filling in the correct box based on what's the heading is up there. Because on the previous page, I think we wrote true first and then false. So don't get into weird habits. Make sure you're reading carefully. All right, so we got to find the median of each guy. The median is the middle number in the set of data. So I have to write out the data. So I'm going to put them in order from least to greatest. So for Mark, 37 is the smallest number. And I would separate it by commas. Then 42, and then 44, and then 47. And then for Caesar's data, it goes 44, 45, 46, and 48. Okay, the middle number. So, oh, there's an even number, so the middle number would have to be right here. So to find the middle number, you find the mean of both of these. So you go 42 plus 44, and then divide it by 2. And that would give you 43. Okay? And the middle number in between 46 and 45, or 45 and 46, is 45.5. Or you can go 45 plus 46, press equals, then divide it by 2, and you get that middle number. So that's the median, because the median is the middle number. And up here it says the median Mark score is less than Caesar's. Is this less than Caesar's? Yep, that's true. Say true, true. Okay, the range of Mark scores is less than the range of Caesar's scores. So it's nice that I have the data right here, because to find the range I take the highest number minus the lowest number. So I can do that since it's already written there. It's nice and easy. I don't have to try to fish through the data and chance making a mistake. 47 minus 37 is 10. And 48 minus 44 is 4. So the range of Mark's scores is less than Caesar's scores. Nope, Mark's range is larger, so this is a false statement. Emma and Denise are selling candy bars. The amount they sold each day last week is given in the table. Determine whether each statement about the data is true. So it looks like we got to find the mode, the mean, and compare them, and then compare the ranges. So just like we did for the previous problem, you're going to need, you should, you don't have to, but you should find the data down here so that you can compare it. Okay, so you see that there's quite a few numbers up there. I'm going to transfer the data down here, and I want to make sure that I write it in order from least to greatest, okay? It's all scrambled. So I see that would be 4 and then 6. What helps is if you cross it out after you write it so you're not writing the same number twice. And then 12. Cross it off. 25. Cross it off. 25. 32. 41. Okay, so you cross them off so I know that I got them all. Then Denise's, kind of running out of room here. I should write smaller. 10, 12, 14, 16, 29, 33, 39. And the reason I was able to do that so fast is because I already did these problems ahead of time, and I already got the information. So I kind of want to make this more of a shorter video, hopefully. But you're responsible to be pausing the video periodically so you can practice them without just copying it. Because honestly, if you're just copying it, you can't copy on a test, so you're just really setting yourself up to not do as well. If you're literally working out the problems, that's what you're going to be doing on the test, so you're simulating a test environment, and that's going to help you be more successful. So really just take my advice, okay? Okay, so mean for Emma, add them all up, divide by how many there are. You should get, I'll round to nearest hundredth, 20 and 71 hundredths. And then Denise's, you add them all up, divide by how many there are, and her mean is 21 and 86 hundredths. So the range, because we got to find the range too, take the highest minus the lowest. Highest value minus lowest value, 41 minus 4, and I think that's 37. And then the range for Denise, highest number minus lowest number, 39 minus 10 is 29. So now we just compare it. So the mode of Emma's sales is 41. No, her mode is 25. Mode means most. So that's false. The mean of Emma's sales is more than the mean of Denise's sales. So go ahead and compare it. Put your answer. I got false. Let me know if I mess up. The range of Emma's sales is less than the range of Denise's sales. That's false because Emma's range is larger. Jay and Kobe are competing against each other in a pie eating contest. The number of pies each boy consumed each hour is shown in the table. Oh, we have some decimals in here. Determine whether each statement about the data is true. So we got to compare the median, the range, and the mean. So write really small so you can write your information. So I'm going to have Jay, Kobe. I'll write down Jay's information. Okay, in order from least to greatest. Kobe's is this right here. Okay, so the median is the middle number. Oh, look, we have an odd number of data pieces, so that's easy. So I know 3's in the middle for J. Kobe's is 4. That is a comma. Okay, and then the range for J, go 6 minus 1.5. And you would get 4.5. And then the range for Kobe is 7 minus 2 and 25 hundredths, and you would get 4 and 75 hundredths. And then the mean for J, add them all up and then divide by how many there are. So 1.5 plus 3 plus 6, press equals, then divide by 3, and you should get 3.5. And then for Kobe, go 2 and 25 hundredths plus 4 plus 7, press equals, then divide by 3. And his mean is 4 and 42 hundredths, unless I messed up. Okay, so after you've compared them, you should get true, true, and false. If you just copied what I did without analyzing what you did, that was really not a good move. Okay, go back and analyze it. Don't be lazy. Okay, Kylie wants to estimate the number of students in 7th grade who are interested in starting a book club. She needs to create a random sample of students. How should she collect the data? So what I want you to do first is identify the population. Who are we interested in studying? And it's the students in 7th grade. That's the population. Okay, and we got to find a representative sample of the students in 7th grade. So where should she collect the data? How should she? She asked 30 students in the library. Nope, that's kind of biased right there because not everyone's got an equally likely chance of being selected because they're all in the library. She asked 30 of her closest friends. Nope, that's not random at all. Those are people she knows. She knows every single one of them, and they're more likely to probably vote a certain way. She asked 30 students in the 7th grade. That should fit the criteria, but let's double check the last one. She should ask 30 students in the whole school. Oh. But remember, the population is students only in the 7th grade, so that's what we're interested in. We don't care about the whole school. That would be too many people over what she's interested in. So the answer is C. Remember, for it to be a good sample, it's got to be unbiased, which means it's fair. It's got to be, there has to be enough people in the sample, and there also has to be the people or objects or things in the sample have to be randomly selected, which means each item or thing needs an equally likely chance of being picked. Okay, Vanessa wants to estimate the number of students in 7th grade who are interested in starting a baking club. She needs to create a random sample of students. How should she collect her sample? So again, your population is students in the 7th grade. So you want a representative sample of that population. Okay, should she ask 30 students in the girls' locker room? Nope, that's biased because there's boys and girls in the 7th grade, so that's not going to work. Ask 30 students who are related to her? Nope, that's not random. Ask 30 students in the 8th grade? No, they're not even interested in the 8th grade. They want 7th grade. Ask 30 students who are in the 7th grade. There it is. Okay, Gavin wants to estimate the number of boys in the whole school who are interested in joining archery club. He needs to create a random sample of students. How should he collect the sample data? So they're interested, the population is the boys in the whole school, okay? So that's the population that he's interested in collecting data about, or for, or about, yeah. So ask 100 boys in Moses Lake. No, that's too big. Ask, because they don't want in the Moses Lake, they want to know in the school. And it looks like it could be any grade level. Ask 100 boys who walk into the school on the way to class. That seems like it's right. Ask 100 teachers in the town. No. Ask 100 coaches in the state. Nope, it's this one. Remember, it's got to fit that 3 criteria, and we took notes on that. Okay, the box plot shows information about the number of push-ups Erloy and Amaya did each day for a month. So here's Erloy's data here. Here's Amaya's. How much greater is the interquartile range for push-ups done by Erloy than Amaya? So let's go ahead and find the interquartile range. I'm going to abbreviate that because I don't have much room here. I'm going to call IQR, interquartile range. So to find the interquartile range for Erloy, for actually all boxing whisker plots, you take the upper extreme minus the lower extreme. So it'd be 60 minus 30, which is 30. Okay, for Amaya's, her interquartile range, upper extreme is 60, upper quartile is 60, lower quartile is 40. I hope I said that right up here. It's quartiles. Upper quartile minus lower quartile. Upper quartile minus lower quartile. So 60 minus 40 is 20. How much greater is the interquartile range for push-ups done by Erloy than Amaya? You would literally go 30 minus 20. So your answer is 10. Okay, what percentage of Amaya's data is 60 or above? So I'm just looking at Amaya's. Find the 60 or above. So remember, each little section, no matter how long it is 25%. So 25%, 25%, 25%, 25%. The reason this one's longer is because these numbers that fall in that section, they're all spread out. This one's smaller, this little section is smaller because all those numbers are all smushy together, okay? So anyway, 60 or above, so here or above, that right there is 25%. Okay, the box plots show information about the number of hot dogs eaten by Andrew and Taylor each day for a week. So we got Andrew's data and Taylor's data. How much greater is the range for the number of hot dogs eaten by Taylor than Andrew's? We got to find the range for both because we have to compare them. Okay, range is upper extreme minus lower extreme. So this would be 9 minus 3, which is 6. Taylor's range is upper extreme minus lower extreme, 10 minus 2, which is 8. How much greater is Taylor's than Andrew's? Taylor's has 8. Andrew has 6. 8 minus 6 is 2, so that's the answer. What percentage of Taylor's data is 6 or below? So look at Taylor's. 6 or below. Go ahead and write that down without copying me. So it's actually 25 plus 25, which is 50%. Okay, the box plot shows information about Gabby and Dylan's test scores over the year. How much greater is Gabby's lower extreme than Dylan's? So let's find lower extreme. I'm going to abbreviate it, lower extreme. Or you could call it the minimum. So lower extreme right here is, oh, we should fill in this number line. Remember, number lines always jump consistently. So it looks like they're counting 0 to 10. So 10, 20, 30, 40, 60, 80, 100. Okay, same with Dylan's. Fill it in so you don't screw up later, okay? Don't skip that step. I know it takes like 2 seconds, but just do it so you don't mess up. Okay, what was I talking about? Lower extreme. So lower extreme right here is 60. Lower extreme right here is 50. How much greater is Gabby's than Dylan's? 60 minus 50 is 10. What percentage of Gabby's data or scores are 60 to 90? So find Gabby's. Okay, so 60 to 90. So that's 25 plus 25 plus 25, which is 75%. Okay, the box plot shows a summary of number of miles Serena and Miley walk each day over a period of a month. Number of miles Serena walked, and then Miley walked. Oh, darn it, that number line is kind of blank. So let's see what they're jumping by. 0 to 1, there's one notch in between. So this would be, what's between 0 and 1 exactly? It's 0.5, 1/2. Or you can write it as fractions if you want. I'm just going to write them as decimals, because I think it gives me a little bit more room. Okay, this should help us. Determine whether each statement is true based on the data in the box plots. Select true or false. So first column is true, second column is false. Miley's range is less than Serena's range, and it looks like we're comparing medians, and then we're comparing lower extremes. So let's go ahead and start with the range. So Serena's range, remember it's upper extreme minus lower extreme. So it's 5.5 minus 1.5, which is 4. Okay, and then Miley's range is upper extreme is 6, lower extreme is 1/2 or 5/10. So 6 minus 1/2 is 5.5. Okay, so it says Miley's range is less than Serena's range. No, it's not. Wait. No, it's not. Yeah, Miley's range is bigger, so that's false. Serena's median is less than Miley's median. So what is the median here? Median right here is, hers is 4, hers is 3.5. Serena's median is less than Miley's median. No, it's not. Serena's is bigger, so false. Serena has a higher lower extreme than Miley, so let's find lower extreme. There it is. So Serena's is 1.5, Miley's is 5/10. So yes, Serena does have a higher lower extreme than Miley, so that's true. Okay, these box plots show Dariel's number of sit-ups and Olga's number of sit-ups each day over a period of a month. And it looks like we're comparing median, upper quartile, and interquartile range. So Dariel's median is equal to Olga's lower quartile. Okay, Dariel's median is right there. And that is equal to Olga's lower quartile. That's true. Okay, Olga's upper quartile is 20 less than Dariel's upper quartile. So here's upper quartile. Dariel's is 50. Olga's is 70. Olga's is 20 less than Dariel's. Nope, it's the other way around, so this is false. Okay, interquartile range. We got to find that out. Interquartile range for him is 50 minus 30, which is 20. Hers is 70 minus, oh, I should fill that in, 40. 70 minus 40, sorry, is 30. Okay, so the interquartile range of Daryl's data is more than Olga's. Nope, Olga's is bigger, so this is false. Okay, this shows Briar and Ella's number of customers in their restaurants, and I can see that we need to find the median, inner quartile. Oh, look at the median and upper quartile. So Ella's median is the same as Briar's upper quartile. Let's find Ella's median. There's Ella's median, and it's the same as it's the same as Briar's upper quartile. That's true. Okay, Ella's inner quartile range is the same as Briar's. Let's figure out inner quartile range for each. So this would be 250 minus. That says 250 minus 100, which is 150. Ella's is 300 minus 200, which is 100. So Ella's inner quartile range is the same as Briar's. Nope, it's not. Okay, Briar has a greater range. Let's find the range. Upper extreme minus lower extreme. I don't know why I wrote ranger. It's range. 350 minus 50, which is 300. Ella's range is 450 minus 100, which is 350. So 350 and then 300, that's 300 right there. Briar does not have a greater range, Ella does. Representative sample of 100 7th grade students. 100. Is surveyed. Each student is asked what his or her favorite animal is. The table shows the responses. Select all of the statements that are valid based on the results. Okay, I gotta figure out. Okay, there's 100 students surveyed, so this plus this plus this plus this should equal 100. Okay. Of the 7th grade students surveyed, 30% prefer gerbils or rabbits. So gerbils or rabbits. Gerbils or rabbits. So I'm going to go 16 plus 14, which is 30. 30 out of the 100 equals 0.30, which equals 30%. Gerbils or rabbits, that's true. Okay, so let's check that box. Okay, of the 7th grade students surveyed, 1/5 prefer cats. So it would be 20 out of 100 prefer cats. Let's divide both by 20 because 20 goes into 20 and 100. 20 divided by 20 is 1. 100 divided by 20 is 5. 1/5, that's true. Okay, in a group of 200 7th grade students, it's expected that 100 would prefer dogs. So we have 100 right now. Right now that prefer dogs is 50 out of 100. And we want to set up a comparison to where now we're saying, oh, I want 200 students. How many would prefer dogs? So see here, like we've been practicing in class, 100 times what number is 200? Well, it's times 2. So go 50 times 2. So if there were 200 people surveyed, 100 of them would prefer dogs. So that's true. In a group of 50 7th grade students, it is expected that all would prefer dogs. Okay, so remember the thing with the dogs. There's 50 out of 100 in this data. We want to make sure it's proportional. So they're saying there's 100 students, 50 of them would like dogs. So if there were 50 students, how many would like dogs? So right here, we're going 50. We can go 100 divided by 2 to get 50. So go 50 divided by 2 to get 25. So does it show in a group of 50 7th grade students, it's expected that all would prefer dogs? No, because only 25 would prefer dogs. So this is false. Okay, representative sample of 200 middle school students is surveyed, and they were asked what their favorite types of chips are. The table shows the responses. So all these, when you add them, go ahead and double check, should add up and equal 200, because that's how many middle school students were surveyed, and this is the results. Okay, select all statements that are true based on the results. Of the 200 middle school students surveyed, 20% prefer Doritos. So let's find Doritos. 40 out of 200. Go 40 divided by 200, that's 0.2, which is 20%. Yep. In a group of 400 middle school students, it is expected that 58 would prefer Funyuns. So what do we have right here? We have 28 out of 200 like Funyuns. And so we need to go, we want out of 400 this time. 200 times 2 is 400. 28 times 2 is 56, not 58. So that is not true. Okay, there's 1.25, 1 in 2,500 times as many middle school students who prefer Doritos as prefer barbecue. So that means Doritos they like Doritos more, okay, by 1.25. So if we took the barbecue amount, we should multiply it by 1.25 to get the Dorito amount if this is true. So barbecue amount is 32 times 1.25 times, and if that equals the amount of Doritos, we're right. So if you type that in, or do it in your head, you would get 40, so that is true. Okay, of the 200 middle school students surveyed, 100% prefer hot Cheetos. So let's see how many like hot Cheetos. 100 out of the 200. 100 divided by 200 is 0.5, which is 50%. That's not 100%, so that's not true. Okay, a representative sample of 50 7th grade students was surveyed, and they're asked what their favorite subject is. Oh, look how high math is. That's nice. Okay, select all of the statements that are valid based on the results, and we know that these all are 50. Okay, there are 2.5 times as many 7th grade students who prefer English as prefer math. That means they like English better. So we would go, they like English better than math. So you would take math times 2.5, and you should get the amount of English, but that's impossible because English is lower. So you'll see that that is false. 62.5 is what English should be, since English is 2.5 times more than math. So that's not true. Okay, in a group of 7th grade students where 20 prefer science, it's expected that 21 would prefer English. So English is one more than science in this data, but it's not always going to have, science is not always going to be one less than English, because remember you have to maintain the ratios like we did over here. So let me go ahead and just make up an example just to show you that English is not always one more student than science. So for example, right now as it is, it's 8 out of 50 for English, and for science it's 7 out of 50, okay? Now let's pretend that we had 100 students who were surveyed. 50 times 2 is 100, so 8 times 2 is 16. Okay, 50 times 2 is 100, so 7 times 2 is 14. Do you see how they're not separated by one vote apart? So this is not true, okay? Because it's not always going to be, like if this is 10, this one won't be 9. If this is 22, this one will not be 21, okay? Okay, it's expected that 100 would prefer math if 200 students were surveyed. So let's see how it is now. 25 out of the 50. But now they're saying, instead of 50 students, we want 200 students. So what are we multiplying by? We're multiplying by 4. So 50 times 4 is 200. 25 times 4 is 100. So it's expected that 100 prefer math if 200 students were surveyed. Yep. Of the 7th graders surveyed, 25% prefer math. So it's 25 out of the 50. 25 divided by 50 is 0.5, which is 50%. So this is not true. The middle school principals are deciding whether to buy new wrestling mats or a new scoreboard for the basketball court. Which sampling method would give them the most accurate idea as to what most students would want to be purchased? So figure out your population. Sometimes it's not very explicit, but we know that our population is middle schoolers, middle school students. Okay, so we want a sample that represents middle school students. Remember, it's got to be unbiased, which means fair. It's got to have enough participants. So if they were only just to ask like one kid in each grade level, that's not enough participants because we have like, I don't know, 800, 900 kids or so. And it's got to also be random. Each person's got to have an equally likely chance of being selected. So ask a random sample of students on the wrestling team. No, that is biased. We want to be unbiased. Biased means not fair. Ask the 8th grade math is cool team. Nope, that's too narrow of a sample because we're interested in all middle school students in the school. Ask every 5th student who enters the school. Yeah, that's unbiased. There's enough participants and it's random. But let's double check the last one. Ask the basketball coach. Nope. So it's C. Okay, the city council is deciding whether to fund the building of a new dog park or building a new boat launch. Which sampling method would give them the most accurate idea as to what most citizens want? So our population is the town's citizens. Okay, it's got to be representative of that and fit this criteria. So ask every 50th person in the town's phone book. Okay, that sounds good. Ask the Fisherman's Club. Nope. Ask the local veterinarians. Nope. Ask every citizen in the whole state. That's too many participants because we're only interested in the town's citizens. So it's A. Okay, the CMMS principals are deciding whether students should go to a Seattle Mariners baseball game or Seattle's Pacific Science Center for a field trip. Which sample will be the most accurate representation of what the students would prefer? So again, our population are the CMMS students. Okay, should they ask all the teachers? Nope, that's not representative of the population. Ask the school softball team. Nope, too biased. Ask the school science club. That's biased too. Ask every 5th student in the student directory. That's it, because it's unbiased, enough participants, and it's random. Okay, Timothy has a fair 6-sided cube with colored faces. Okay, so I know they're 6-sided. It's fair. It's like a normal looking cube. And it's got faces, and he rolls it 430 times. He recorded the color that was facing up after each roll. So basically, he did this using experimental probability and recorded the results, okay? He recorded the color that was facing up after each roll. His results are shown in the table. So he rolled it 430 times. So these should all add up to 430. And they do. I checked it. But you should double check it because I make mistakes. Based on the table, what's the most likely number of sides of Timothy's cube that are gray? All right, so the way I do this is I just take, I know that they roll it 430 times because it says. And I know that there's 6 sides, so I'm going to divide it by 6. And that's approximately 72 lands per side if all colors were represented equally. But I can tell just from the data that all colors are not represented equally. What I see here, if it was all equal, I know one side would have 72 lands on it. So I can kind of gather that the gray side has one side. Green, that's almost 72, so that's one side. Yellow, that's about double one side, because 72 plus 72 is close to 143, so that's 2 sides. And then 145 is also close to double one side, so that's 2 sides. So 2 plus 2 is 4, 4 plus 2 more is 6, so that adds up to the 6 sides. So I can say that gray is most likely going to have one side. Okay, Philip has a fair 12-sided. That's important. And those do exist because I Googled it to double check. So Philip has a fair 12-sided cube with colored faces. He rolled the cube 500 times, and he recorded the color that was facing up after each roll. Here's his results. So all these numbers of times rolled, the grand total is 500. So based on the table, what's the most likely number of sides that Philip's cube that are magenta? Okay, so same way. We know that there were 500 rolls total, and there are 12 sides on the dice, or cube, whatever. And that's approximately 42 lands, landing on 42 lands per side if all colors were represented equally. So like, for example, that would be like if every single color had its own side, okay? But we know that's not the case because there's not 12 different colors there. So I know one side would have 42 lands. So let me see here. I don't see 42 lands, but I see that, well, 79 is close to double of 42, so I know this is 2 sides. Oh, there we go. There's double about 2 sides. This one's pretty close, 2 sides. So I have 2, 4, 6 sides. There's 12 sides, so this leaves that. Okay. So that would have about 6 sides that are magenta. Okay, Alexis has a fair 6-sided cube with colored faces. She rolled the cube 250 times. There's her data. So based on the table, what's the most likely number of sides that are blue? So I'm looking at blue here. So I would start again by 250. That's how many rolls there were, divided by the number of sides. That's approximately 42 per side. So I see, oh, that's about 42. So that's about one side. That's about double it, double 42. That's 2 sides. So I'd have 6 sides total. I already have 3 right here, so this right here is 3 sides. Okay, and we're looking at blue, so blue would be 2 sides. Blue, 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 2 sides. Okay, this table shows the outcome of a spinner with 3 equal size sections colored pink, purple, and blue. Based on the outcomes, enter the number of times the arrow of the spinner is expected to land on the blue section if it's spun 50 times. Okay, I figure out how many times they spun it to get this data. So they spun it 100 times. So to get blue would be 32 out of 100. Okay. So we go 32 out of 100, and they're spinning it 50 times. Remember, this right here was the probability of being blue. And so 32 hundredths, or 0.32 times 50, is 16. So they'd expect to land on it 16 times. Okay, this table shows the outcomes of a spinner with 4 equal size sections colored orange, yellow, red, and brown. Based on the outcomes, enter the number of times the arrow of the spinner is expected to land on red if it's spun 25 times. Okay, so let's see how many times they got for this data right here. That plus that plus that plus that. This equals 200. Okay, and we're looking at red. So probability of it being red, given the data from this experiment, the results 48 out of 200. So you take that probability of it being red and multiply it by the 25 spins. Remember, that's probability of it being red. You're gonna spin it 25 times. And when you go 48 200ths times 25, if you're like, oh, I can't do this on my calculator, go 48 divided by 200, press equals, get that decimal, and then times it by 25. You get 6 times. Okay, this table shows the outcome of a spinner with 8 equal size sections colored black, gray, gold, crimson, maroon, white, green, and peach. Based on the outcomes, enter the number of times the arrow of the spinner is expected to land on green if it is spun 80 times. Okay, let's see how many times they spun it here. When you add all these together, double check me, but I got 600. Okay, so the probability of it being green is 75 out of 600. So 75 600ths times 80 spins. Okay, to do this on your calculator, go 75 divided by 600, press equals. That will give you a decimal. Take that decimal and multiply it by 80, and you should get 10 times. Okay, look like this, 75 divided by 600. Okay, don't round it, just keep it in your calculator. And now take that value and times it by the 80 spins. And you get 10 times. Practice that so you will be successful on the test. Marissa is performing a probability experiment. She has a bag of marbles with each marble colored tan, green, brown, or white. She randomly removes a marble, records the color, returns the marble to the bag, and mixes the marbles. She repeats this procedure 100 times. Using the data from the experiment, Marissa makes the following prediction. She predicts that there's about 2 times as many tan marbles as brown marbles. The probability of randomly removing a white marble from the bag is about 1/5. Select the list that could represent the data from the experiment. So really, you have to go with what they give you. I'm going to start here. They give you, there's 2 times as many tans as browns. So there's double tan than brown. So if there's only 10 brown, there should be about 20 tan. Okay, let's see here. Okay, look at brown and tan. Is tan double brown? Yep. Okay, look at tan and brown. Is tan double the amount of brown? No, it's less. So I know that's not it. Okay, tan and brown. Is tan double the amount of brown? Nope. Okay, look at tan and brown. Is tan double the amount of brown? Yeah, about. Okay, so we narrowed it down to these 2. Now look at this. The probability of randomly removing a white marble from the bag is about 1/5. So using this data, let's find the probability of getting white. And same here, probability of getting white. Okay, so when I add these all together, 20 plus 48 plus 11 plus 21, that's 100. And how much is white? 21. Okay? And right here, 45 plus 28 plus 22 plus 5, that is also 100. The probability of getting white is 5 out of 100. Okay? So 21 divided by 100 is about, actually they want to keep it as a fraction. So let's simplify it. So this is a close to 20 out of 100, which is close to 1/5. Right here, 50 hundredths is 1/20th. So the data, or the information Marissa drew from the information is 1/5. So we know that the answer is A, because it just matches both of those criteria. Okay, Miguel's performing a probability experiment. He's got a bag of marbles, which each marble is colored a different color. He randomly removes a marble, records the color, returns the marble to the bag, and mixes the marbles. He repeats this procedure 200 times. Using the data from the experiment, Miguel makes the following predictions. The probability of randomly removing an orange marble from the bag is about 1/5. There are about 2 times as many red marbles as blue marbles. Select the list that could represent that info, or represent this criteria. So instead of starting here, I like starting here. I like the double one better. There's about 2 times as many red marbles as blue marbles. So red is double the amount of blue. Okay, compare red and blue. Is red double the amount of blue? Yeah, about. Is red double the amount of blue? No, it's the other way around. Is red double the amount of blue? Nope, blue's more. Is red double the amount of blue? Yeah, about. Okay, now comes the part where here. We want to remove an orange. What's the probability of removing an orange? Okay, so orange is 10 out of 10 plus 90 plus 44 plus 56 is 200. And let's simplify that. I'm going to divide top and bottom by 10. That's 1/20th. Okay, probability of orange down here. Orange is 42 out of 200, which is, I'm going to divide top and bottom by 2. And that's approximately 1/5. Okay, because it says there are, the probability of randomly removing a marble from the bag is about 1/5. So it's not exact, so that's it. Okay, Jason's performing a probability experiment. He has a bag of marbles with each marble colored purple, pink, teal, or black. He randomly moves a marble, records the color, returns the marble to the bag, and mixes the marbles. He repeats this 100 times. So let's try to figure out which one matches this information. The probabilities of randomly removing a purple marble from the bag is about 1/4. There are about 3 times as many teal marbles as black marbles. So 3 times as many teal than black. So we're comparing teal and black. Teal is 3 times as more. Okay, here's black, here's teal. Is teal about 3 times as more? Yeah. Here's black, here's teal. Nope, teal is less. So that teal is not 3 times more than black. Teal needs to be 3 times as much as black. Nope, black is more, so that's not it. Okay, teal needs to be 3 times as much as black. Oh, it's not here either. So I know for sure it's going to be this, but let's double check the criteria for the second part. Probability of randomly removing a purple from the bag is about 1/4, so probability of purple. And there's 26 out of, add them together, 100, so that's approximately 1/4. You know, it's a little bit more, so that's it. Okay, a spinner with 2 equal portions, a blue and yellow, is spun 2 times. So it's got 2 equal parts, and it's spun twice. Enter the probability of the spinner landing on yellow both times. So I'm just going to draw a quick sketch here. Pretend those are 2 equal portions, blue and yellow. And I want to get yellow both times. So probability of getting yellow and yellow. So the probability of getting yellow is 1/2, and means multiply in probability. Probability of getting yellow is 1/2. So it's 1/4, or 25 hundredths, or 25%. If you're more of a counting tree type person, that's cool too. Start. First spin, you can land on blue or yellow. Second spin, if you land on blue first, you can land on blue or yellow. Blue or yellow. Second spin. We only spun it twice, so your outcomes are blue, 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 yellow, yellow, and then blue, yellow, and then yellow. That's a blue. Okay. So this is our 4 possible outcomes. And we're looking for yellow and yellow. there it is. It's 1/4, which is 25/100, which is 25%. Both ways work. Okay, a spinner with 3 equal portions. 3 equal portions. Red, green, and purple. This is spun 2 times. So I'm going to try to draw that. Pretend these are 3 equal portions. Red, green, purple. And the probability of landing on red all 3 times. Oh, it should say twice, because we only spun it twice. Both times. Sorry, typo. Okay, so we want to get probability of red and red. Okay, so I can go probability of red is 1/3 times probability of red is 1/3, which is 1/9, which is 0.1, repeating, which is approximately 11.1%. Okay, if you're more of a counting tree type person, here's your counting tree. Probability of getting, what did they want? Red, what? Oh, wrong one. Okay, the probability of getting red and red. I have to fix my answer key. Okay, probability of getting red and red is right there. 1 out of the 9 possibilities. So there's your information. Okay. Next problem, try it. Spinner with 2 equal portions, pink and gray is spun 2 times. So I'm going to draw a sketch of that. Okay, I want pink, probability of pink, the first spin, and then gray on the second spin. Okay, probability of getting pink is 1/2, and the probability of getting gray is 1/2, so that's 1/2 times 1/2 is 1/4, which is 0.25, which is 25%. Okay, if you're more of a counting tree type person, here it is. First spin, you can land on pink or gray. Second spin, you can land on pink or gray if you land on pink first. If you land on gray first, you can also, again, land on pink or gray. So you have 4 possible outcomes. There's the pink and then gray, 1/4, which is 25/100, which is 25%. Okay, this table shows the outcomes of a number cube with 6 equal sides, numbered 1 through 6. Okay, I want to figure out how many times they rolled it, because it doesn't tell me that. So add them all together. I think you get 100, right? Double check. Okay, based on the outcomes, enter the number of times the number cube is expected to land on 6 if it's rolled 50 times. Okay, it's similar to your other problem. Someone's already done experimental probability. This is their result. You have to use this. You can't be like, oh, I want a number cube to get 6. It's 1/6. Yeah, theoretically, but right here, they've collected data for you. Use the data. So the probability of getting a 6 is 16 out of 100. Okay, and you roll it 50 times. So 16/100, that's the probability of getting a 6, given this data. When they give you data, you use it. Times 50 rolls. 16/100 times 50 rolls is 8 times. Okay, this table shows the outcomes of a number cube with 6 equal sides. They're numbered 1 through 6. So it looks like they landed on 3 36 times, landed on 1 32 times. Let's see how many times they rolled it. When you add them all together, that means they rolled it 200 times. So based on the outcomes, enter the number of times the number cube is expected to land on 4 if it's rolled 40 times. So the probability of getting a 4 in the data is 30 out of 200. Okay, so you take 32/100, remember 32/100 is the probability of getting a 4 given this data, times it by 40 rolls, and you get 6 times. Okay. Okay, this one, same situation, 6 equal sides, numbered 1 through 6. Here's their data. Let's see how many times they rolled it. Add them all together. You should get 400, unless I messed up. Figure it out. Based on the outcomes, enter the number of times the cube is expected to land on 1 if it's rolled 120 times. So probability of landing on 1, given this data, is 60 out of 400. Okay, so we have 60 out of 400, 64 hundredths. Remember, that's probability of landing on 1. times 120 rolls. If you don't know how to do this, go 60 divided by 400, press equals, and then take that number and times it by 120. And you should get 18 times. Okay, these dot plots show the amount of time spent online by two different groups of students. Okay, so right here represents group A, right here represents group B. Each one of those dots represents one person. These represent the minutes. So for example, there were 3 people that spent 40 minutes on online. And I see that there's blank spots on my number line, so you want to fill those in so you don't screw up later. Okay, same thing here. They're counting by 20s because halfway between 0 and 40 is 20. Halfway between 40 and 80 is 60. We're counting by 20, so 80 plus 20 is 100. 100 plus 20 is 120. 120 plus 20 is 140. Okay, how much greater is the mean amount of time spent online by group A than the mean amount of time spent by group B? Round your answer to the nearest hundredth. Okay, nearest hundredth is 2 decimal places to the right. They want you to round the answer. So if you get a decimal in your mean here and a decimal in mean here, don't round it, just keep it, okay? So the easiest way to do this is to rewrite the data down here, okay? And you need to do that and cross them off as you go so you don't write the same number twice. When you rewrite that data, this is what you get for group A, okay? To find the mean, you add them all together and divide by how many there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. So you add 20 plus 20 plus 40 plus 40 plus 40 plus 80 plus 80 plus 120 plus 160 plus 160 plus 160 plus 180 and divide by, I already forgot how many there were. I think there were 12. Divide by 12, if that's how many there are. And you should get the mean for group A is 91.66666 repeating, okay? So when you type that in your calculator, go 91.6666, as many sixes as you can. Because it says they want you to round your answer. That's not the answer. The answer is when you subtract them because they want to know how much greater one is than the other, okay? Group B's data. Yes, include the 0. See, there's one person that didn't spend any time online. So you include that in your data, okay? So those are your data points. You add them all together, even the 0, and then divide by how many there are, including the 0. There should be, what, 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 12. So add them all together, divide by 12. That's your mean right there, 88.3 repeating. So in your calculators now, because we want to know how much more is this group A than group B, go 91.66666, fill it up, minus 88.3333, and you should get, they want you to round it to the nearest hundredth, so 3.33, okay? All right, the next part. You'll see I forgot to put a notch right there, so put the notch right there, okay? Fill in your number line. See, I put a little thing in my answer key because that was my mistake, okay? Okay, these show Caleb's and Jasmine's scores on tests. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tests they took. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, just double checking. 9 tests each kid took. Okay, like I said before, you're going to write down the data. So you're going to write 70, 80, 80, 80. Separate them by commas. 90, 90, 100, 100, 100 for Caleb's test scores. For Jasmine's, you're going to write 60, 80, 90, 90, 90, 100, 100, 100, 100. Separate them by commas, okay? We got to find the median. So you'll see that they were written in order. The median is the middle number. There is an odd number of data pieces. So the very middle number is 90 for Caleb. The very middle number for Jasmine is also 90. Remember, if there were 2 middle numbers, you would add them together, then divide by 2, and that would be your median. Okay, so to answer the question, how much greater is Caleb's median than Jasmine's? 90 minus 90 is 0. So that's how much greater Caleb's is than Jasmine's. Okay, these dot plots show the amount of time spent on homework by 2 different groups of students. Take a second right now and fill in the blank parts of that number line, okay? Because you'll see it's counting by 0.5. The reason I know it's counting by 0.5 is because halfway between 0 and 1 is 0.5. So we're counting by 0.5. So add 0.5 each time, and that's what your number line should look like, okay? Same with down here for group B. Fill it in. And there's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Yep, there's 8 in each. And you will need to know how much greater is the mean amount of time spent on homework by group B than by group A. Round your answer to the nearest hundredth. So you right now need to write down all those data points. 0.5, 0.5, 1, 1.5, 2.5, 2.5, 3.5, 5 for group A. Right there. Okay, for group B, you're going to write 0, 1.5, 2.5, 2.5, 3, 4, 4, 5.5. Okay, and that is right there. When you find the mean, you add them all together and then divide by how many there are. For group A, that's the mean I got. For group B, that's the mean I got. And you need to subtract group A from group B, because it says how much greater is group B than group A. And you would take that, and when you round to the nearest hundredth, you end up with 0.75, 75 hundredths. Okay, turn to the next page. Okay, a deck of 10 cards labeled 1 through 10 is shuffled. A card is drawn at random and then shuffled back into the deck. This is repeated 2 more times. Okay, so there was a card drawn. It's repeated 2 more times. So that means it happened 3 times. So they did this process 3 times. The card label with the number 7 is drawn 2 out of 3 times. So they pulled out a 7, put it back, shuffled it, pulled out another 7, and then the 3rd time they didn't pull out a 7. So that's crazy. They pulled out a 7 2 out of the 3 times in the experiment, in the experimental probability, okay? The predicted probability, which is, theoretical, of drawing the card with the number 7 when one card is drawn is 1/10. Remember, if you just had it, if I was like, hey, you got 10 cards labeled 1 through 10, what's the probability of drawing 7? You'd say, oh, totally, 1/10. That's what we got right here. But when they did the experiment, remember how experimental probability, when you first do it, like you only do it a couple of trials, it's not going to be very matchy-matchy. Think of that time in class when you were flipping those coins. Remember, the more times you flipped it, the closer you got to the theoretical probability. Okay, think of that. Select the statement that best explains why the observed frequency, that's up here, the experiment, what they observed, is different than the theoretical probability. That's why is this different? The experiment, why is it different than the theoretical one? Because they most likely differ because the sample size is too small. So up here they only did it 3 times. They most likely differ because 2/3, 2 out of 3, and 1/10 have different denominators. C, they most likely differ because a card is drawn more than 1 time. D, they most likely differ because the predicted probability is inaccurate. Okay, think about that experiment that you did in class where you were flipping the coins. The more times you flipped it, the closer you got to your experimental probability matching the theoretical probability. And you'll know that your sample size was much larger for it to be closer. The more times you flipped it, you know your sample size. The bigger that your sample size was, the closer you were to it being matching the theoretical probability. So your answer to this problem is A. They most likely differ because the sample size is too small. They only did it 3 times, okay? So the more times they do it, when you simplify your answer, it's going to be closer to 1/10, okay? So that's the answer. All right, a fair 2-sided coin with one side labeled heads and the other side labeled tails was tossed by Brenda 114 times. And it landed on heads each of the 114 times. What is the probability that the coin will land on tails on the 115th toss? Think about it. Is this an independent event or a dependent event? If it's independent, then whatever happened in the previous tosses does not impact the next toss. If it's dependent, then that would be where like you're removing something. We're not removing one side of the coin. So your probability of it landing on tails on the 115th toss is still 1/2, no matter what happened before it. Okay, a standard 6-sided cube labeled 1 through 6 is rolled 3 times. The side labeled with the number 3 is landed on 2 of the 3 times that the cube's rolled. What's the predicted probability of landing on the side labeled with a 6? So, probability. Actually, I want you to change it to a 3, just to make it a little bit more confusing. All right, so here's what really happened in experimental probability. Predicted probability is theoretical, you know, they're predicting like what would happen. So what's the probability of landing on 3 in the predicted sense? Well, it's numbered 1 through 6, so 1 out of 6. That's your answer. Okay, I'm not going to consider these complete until you actually fill this all out, okay? Turn it in, bring your questions to me. Good luck on your test. You don't need luck if you study, study, study. Answer these questions thoughtfully and thoroughly. I'm going to be looking at them. Bye.